Hi, I'm Miss Hall, and this is Lesson 79, Sample Spaces and Theoretical Probability. We'll begin with sample spaces. A probability experiment is an action or trial that has varying results. The possible results of a probability experiment are outcomes. For instance, when you roll a six-sided die, there are 6 possible outcomes: 1, 2, 3, 4, 5, or 6. A collection of one or more outcomes is an event, such as rolling an odd number. The set of all possible outcomes is called a sample space. Example 1, finding a sample space. You flip a coin and roll a six-sided die. How many possible outcomes are in the sample space? List all the possible outcomes. This should be review. And there are, I'm going to say, many approaches to this problem. You're going to get the same number of outcomes. One approach you may be familiar with is drawing a sample space, a tree diagram, where the first event is heads or tails, is the coin flip. And then from heads, you can get the numbers 1, 2, 3, 4, 5, 6. Same from tails, 1, 2, 3, 4, 5, 6. Okay, so we need to list all the possible outcomes. I'm going to choose to list them as H1, H2, H3, right? That's getting a heads and rolling the number on the die, 1 through 6, and tails 1, tails 2. Maybe you could have gone right to listing the outcomes. There is no need to draw the tree diagram if that's not helpful for you. So we list the possible outcomes, and I see that there are 12 possible outcomes. We're supposed to list them, and there are the 12. Our second topic, theoretical probabilities. The probability of an event is a measure of the likelihood or chance that that event will occur. Probability is a number from 0 to 1, including 0 and 1, and can be expressed as a decimal, fraction, or percent. Okay. As a reminder, if the probability of an event is 0, it means it's impossible or not going to happen. So if you're rolling a six-sided die, the probability of rolling a 7, for example, is 0. And then 1 is that it's absolutely going to happen 100%. What's an event that's going to happen 100%? The likelihood that the sun will come up tomorrow is 100%. It is certain that the sun's going to come up tomorrow. The outcomes for a specified event are called favorable outcomes. When all outcomes are equally likely, the theoretical probability of the event can be found using the following. Theoretical probability equals the number of favorable outcomes over the total number of outcomes. The probability of event A is written as P of A. Example 2, finding a theoretical probability. A student taking a quiz randomly guesses the answer to 4 true or false questions. What is the probability of the student guessing exactly 2 correct answers? The first step to this problem is listing the sample space. The second step is then identifying the favorable outcomes, 2 correct answers. And then the third is writing it as a probability of favorable outcomes over possible outcomes. So listing the sample space here, again, there's a couple of approaches you can take. I do like the way the book does this. So we're going to list out, what if there are 0 correct answers, 1, 2, 3, or 4. Okay. For 0 correct answers, and there's 4 true or false, I'm going to list incorrect, 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 incorrect. Similarly, for 4 correct, it is correct, 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 correct. So that is my key. I is for incorrect, C is for correct. Okay, so if you get 1 correct answer, it could be the first answer that you get is correct, or it could be the second answer that you get is correct, or it could be the third answer that you get is correct, or the last answer that you get is correct. For me, visually, I see the C moving through the 4 possible spaces. I am then going to skip to the 3 correct. And here I'm going to have the incorrect move through the 4 positions. So either the first one was incorrect, or the second one was incorrect, or the third one, or the fourth one. Okay, now 2 correct. I have to list all the possible combinations with 2 C's and 2 I's and tell you how I think about it. I'm going to stick with the 2 C's are going to be together first, and they're going to move through the 4 possible spaces. So locked together, they could be the first pair, they could be the middle pair, or they could be the last pair. Now we're going to put 1 space between them. So they could start at the front and have a space between, or they could start one end and have a space between. And what if they had 2 spaces between them? That would be C, I, C. And are there any combinations I'm missing? They can't have 3 spaces. No, so I've got them all covered. We put the total number of outcomes. So there's 1, 1, 2, 3, 4, 4, 3, 4, 5, 6, 6, 4, 1. There are 16 possible outcomes, and we want to know what is the probability of the student guessing exactly 2 correct answers. So the probability of exactly 2 correct answers is going to be 6. There are 6 possible outcomes with 2 correct answers. Over 16 possible outcomes, we can reduce that. Divide top by 2, bottom by 2. So 3/8. Or as a percent, this is 37.5% chance when a student is randomly guessing 4 true or false questions that they get exactly 2 correct.